Okay, I just realized there was a second part, so I ended the other video a little too early. Okay, so for this part, we're going to write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, oh, that should be of instead of or, and the given zeros. Okay, so for number 5, we're given -1, 2, and -3i as our zeros. So all the zeros can be written as x minus the number. So that means for x minus 1, that becomes x plus 1. And then for 2, that's x minus 2. For -3i, that's x plus 3i. And don't forget the conjugates theorem. So since we have -3i, that means we also have positive 3i. So that'll become x minus 3i. Okay, so we want to write the polynomial function, so that means we have to multiply this out. I would multiply the real numbers together and the imaginary numbers together. So for the real numbers, that'll become x squared minus 2x plus x minus 2. And then for the imaginary, this is actually difference of two squares. So that's a plus b times a minus b equals a squared minus b squared. Okay, so that's going to be x squared minus 9i squared. And we know that I squared is -1, so this is really x squared plus 9. Okay, and then we can simplify the first part to x squared minus x minus 2. Then we'll have to multiply this. So we get x to the 4th. I'm distributing this way, by the way. So I'm going from left to right. Okay, so we get x to the 4th minus x cubed minus 2x squared plus 9x squared minus 9x minus 18. So that's x to the 4th minus x cubed plus 7x squared minus 9x minus 18. So the lowest degree of this problem is 4, since we have 4 zeros, and the leading coefficient is 1. Okay, next we're given 4 minus rad 5 is a 0. So that would be x minus 4 minus rad 5. And that means we also have x minus 4 plus rad 5. So we have the conjugate. So I'm just going to rewrite this without all the parentheses. So that's x minus 4 plus rad 5 and x minus 4 minus rad 5. Okay, and when we multiply these this could actually be a difference of two squares again. So if we group these two and call this our A, and the rad 5 is going to be our B, that would be x minus 4 squared minus 5, because rad 5 squared is 5. So now we just have to figure out what x squared minus 4 is. So if we use the special theorem, that's x squared minus 8x plus 16, and then we have our minus 5. So it's going to be x squared minus 8x plus 11. So this would be the polynomial. Okay, last section is Descartes' rule of signs. So the number of positive real zeros of f is equal to the number of changes in the sign of the coefficients of f of x, or less than this by an even number. And the number of negative real zeros of f is equal to the number of changes in the sign of the coefficients of f of negative x, or less than this by an even number. Okay, so what we want to find first is f of negative x. So that just means we're plugging in negative x for all of the x's. So what I kind of think about is negative x squared will stay positive, and any positive exponent, it'll stay positive. But for any odd exponent, it'll turn negative. So this would become negative x cubed minus 4x squared. It's not going to change sign because the x squared is going to be positive, minus 8x plus 7. Okay, so next we want to look at the number of times that it changes signs. So in the first one, it changes from positive to negative, and then from negative to positive, so that's 2 times. So that means for the positive zeros, we have 2 or 0. So it's going to be the same number of times that it changes, or less than that, but an even number. So I just subtract 2 each time. And then we don't write any negative numbers. Okay, then for the negative one, we go from negative, negative, negative to positive. So it changes from negative to positive here. So that means for the negatives, we have 1. Okay, so then that means for the imaginary. So the exponent is 3. So that means the total number of zeros should be 3. So if we have 2 positives and 1 negative, that means we have 0 imaginary. If we have 0 positives and 1 negative, then that means we have 2 imaginary. So you just want to make sure that when you add them up, it should equal 3. Okay, next one, we're going to do the same thing. So g of negative x. So I'm just changing all of the signs for the odd powers. So x to the 6th minus x to the 5th minus 3x to the 4th minus x cubed plus 5x squared minus 9x minus 18. Okay, so in the positive one, we have 1, 2, 3. We have 3 sign changes. So for positive, that means we can have 3 or 1 of them. 3 or 1 positive zeros. Okay, then for the negative, move this down a little bit. Okay, so we have 1, 2, 3. So we also have 3 or 1 negatives. Then for the imaginary, so the highest power is 6. That means we can have a total of 6 possible zeros. So if we have 3 positive, 3 negative, we'll have 0 imaginary. If we have 3 positive, 1 negative, then that means we'll have 2 imaginary. If we have 1 positive, 3 negative, that'll be 2 imaginary. And 1 positive, 1 negative, that'll be 4 imaginary. Okay, and that's it. Bye!